Okay, so today we are going to repair this Ender 2 Pro printer. It has problem with X gantry. It is wobbly on both sides, left and right, and it was brought to me because it had cloggage in the nozzle and it needed replacement. So we are going to do general service repair, or whatever you want to call it. We are going to repair every mistake that this printer has, small or big. Now I am removing extruder. I decided to put Creality Tech extruder, something like that, but we'll see at the end of the video that I replace it with all metal Creality extruder, same as original plastic one, but only in metal, in aluminium, because I want this to work as much as possible without my intervention, because it is a printer from the school. Now I have replaced this extruder, and as we can see, this pneumatic release vent is hitting Z axis. That is one of the problems. The next one is whoever assembled this 3D printer did not correctly assemble it, because cable management is terrible. These X gantry cables are hitting Y hotbed axis, and it's not good. Now I am removing hot end, and it is in perfect condition. There is no leakage or anything. This printer was not used for 3 or 4 years. Then the filament that was used was old, and it broke easily. It was full of moisture, it degraded, and I think that is the reason why it got clogged. Now I am removing Z-axis vertical, horizontal profile in order to remove X gantry. And as we can see here, it is wobbly on the left side, where 2 screws are holding this X gantry profile, and no matter how much I try to tighten it, it is not, it cannot be tightened good enough. So what I decided to do was I first experimented with a couple of solutions, and later on I found high quality screws that had a little bit too big head, and I had to file that head and replace these screws. These screws went all the way through this profile of X gantry, and on the other side was the nut. And with this approach I made sandwich, and connection was solid. So I solved wobbling on the left side where 2 screws were, and on the right side I adjusted the eccentric nuts, and we are going to see that later. As we can see, these are replacement nuts, and on the left side upper corner we can see like the marks, because the head of this screw was too big. In order to fix this, I had to file the heads of these screws, and then everything worked fine after that when I put it back together. And this is how it looks. And now I need to talk through all this video, because when cutting this video in shorts, in parts where I talk, it will be easier to recognize what chapter of the video is it. So now, as we can see, I am trying to insert nut and screw correctly. For this endeavor you will need a lot of different screwdrivers and inbus sizes and so on. Now these nuts are used for 3D printers to assemble them, to tighten things together, to hold these profile parts with one another and so on. This is the only way that I managed to solve this problem. I tried 3 different methods, but it did not work. Now these screws are long enough so that they won't hit this extruder assembly, and there is no problem with moving extruder assembly along the profile. Now we can see these marks here on the left side. It is because the heads of the screws are too big, and we need to remove 2 millimeters from the heads of the screws. Now these heads are really big, like 6 millimeters or something like that of impulse length that is going inside this nut set. So I can, after removing 2 millimeters from the top of the head of the nut, I had enough meat, let's say it, enough space to unscrew these screws and screw them back on. So it is not permanently fixed in the place, these screws. Now it is important to clean everything correctly after this, because we do not want these small particles of metal to end up on motherboard and probably fry it. So cleaning at every step is necessary, and we can see here that I successfully put this X gantry in the place. I did this test fitting and everything worked fine. So as we can see here now, there is clearance, and head of the nuts are not hitting the extrusion alloy, extrusion profile. And that's it for this gantry. Now we will need to put everything back together correctly. To screw the horizontal profile at the place. And we can see the process here. I did additional first step was only to screw them in the place. Then I used a torque tool in order to tighten it as much as possible. I placed a spool holder on the correct side of the 3D printer. Now these T-nuts are sometimes hard to get right and tight. So now I am tightening the screws with torque tool, and the first step of calibrating this gantry is done. Now what I'm going to do is to fix hot end. These old Creality hot ends have fix of Bowden tube for Bowden tube. So idea is to cut small parts of Bowden tube that is no longer usable and to place it in the hot end. Then we have a plastic cap that goes on top of that tube, and then on top of that we have our original tube. And we are going to use this fix in order to prolong life of this 3D printer. Of course, we can always replace it with a 3D hot end for easier use, but on tight budget, I do not have many options. Now I am heating this hot end assembly with external power supply, and I am removing hot end nozzle, and as we can see, there was cloggage of old filament that was not that happened as usual because the original Bowden tube was lifted 2 millimeters above the surface of the hot end nozzle, and the plastic escaped on the sides and clogged the hot end. Now what I am doing is I am removing now particles from inside of the nozzle as much as possible, so that I can later on easily unclog this nozzle when I mount it on 3D printer. Now with this tool we can cut the hot end Bowden tube part to the length and cut it flat with the surface, so that the leakage in the contact zone between the hot end nozzle and heat break will not be fatal in our case. Now I'm using blue Odin tool because online they say it has better properties than white one. Now in order to tighten this hot end nozzle properly, I used torque tool set at 1.4 Newton meters. Now I'm cleaning the nozzle, and when there is sufficient heat, I'm going to tighten it to 1.4 Newton meters, and that will ensure proper surface contact between all parts inside this hot end assembly. Now that everything is done, I'm going to mount it back to the extruder gantry or onyx gantry, and I'm going to put everything back together. Important part when putting everything back together is to properly tighten the screws for temperature sensor or thermistor. Reason for that is because thermistor is connected directly through, of course there is usually small resistor in the input, but thermistor connects directly to the mainboard chip, and if we shorten the legs of this chip with over tightening, or if they are touching heat block, it can shorten the chip. Chip will work and it will give image, but after some time from the heat of the shortage, it will destroy the motherboard or destroy the main chip, and my motherboard will not work. So my practice is always, when replacing hot end, to check and clean mainboard, and we are going to do that later on. Now I am doing cable management. I am tightening everything back together, and important part is also not to tighten anything to Bowden tube. I did this just temporarily. At the end of the video you will see that I removed these zip ties because it can limit the filament. Now I'm going to put some grease on the set screw, or I'm going to do that later on. Now when doing cable management with this type of the printers, in my opinion it is good practice to use cables, to put cables for the hot end at the back, because these cables for extruder and X stepper motor are used as some kind of chain to direct the cables. So now I am removing the cover in order to check the thermistor resistance. Usually on room temperature at around 20 to 30 Celsius, it is around 100 ohms, kilo ohms, something like that. It needs to say 100, from 80 to 110. So that is the important part. As we can see, this printer was not used a lot. It is really clean inside. There is no debris inside. I did my best at cable management, and now I am going to see where TH value, thermistor heater, is located. Nije thermistor nego extruder heater. Now it is at 107. That is good, and I'm going to put everything back together. And yeah, so yeah, this is straightforward process. I don't know. I did this probably 50 times now, so it is like I don't know, easy practice to me. And I usually listen to some podcasts while I'm doing this, so instead of running I am fixing printers. And as we can see now, the cable management is done correctly, everything is good, thermistor is reading correctly, so there is no problem, there will not be any problems if we turn on this printer. What I'm doing now is I am adjusting X gantry and Y gantry cable management, and now everything looks fine. And now we are going to put some grease. I am putting Bumble Up grease because I got like 10 packages of Bumble Up grease while fixing their printers, and Yeah, I have enough of these packages around, and Bambola printers are not easy to fix. I would just say that they are not user-friendly at all. Even if you get replacement parts for them, it is not easy to replace them. They are locked. Yeah, they're headache. I like Clipper and I like Freedom with 3D printing. Now, what I'm going to do now is I'm going to clean this glass surface. I'm using 96% ethanol. In my country, in Bosnia, we use it for beekeeping, for bees. That's what they tell me, and for industrial purposes, for glue removal. So I'm removing all the glue that was put on the surface of this printer. There was too much glue. Because I want to see if I will get the perfect first layer after calibrating X gantry. Now I am adjusting eccentric nuts for bed. We need it to be sturdy and not to move a lot from the left to the right. This X gantry levelers can be downloaded from Thingiverse, and by finally adjusting X gantry eccentric nut on the left and the right side, we can adjust right resistance of the wheels so that they will hold to the aluminum extrusion profile, but also move at same pace, so that one side will move 1 millimeter and other will move 1 millimeter, and they will have same reference start point because we are using this 3D printed tool. It's important for left side or right side not to be too tight or too loose, because we want them to move simultaneously. That is the main problem with this, one of the main problems with this one stepper motor for Z-axis printers, calibration of the other side. So after I have done this, I am turning the printer on and everything works fine. Nothing is smoking, so that's good. Now I have notice that this extruder is not correct for this 3D printer. I was trying to adjust the extruder gear in order to grip the filament correctly, but this extruder was from Delta 3D printer, and it had some different characteristics that are not usual for this 3D printer. Now what I'm going to do is to unclog the extruder. I am now moving the Z-axis up, checking with torque tool that everything is tightened correctly at 1.4 Newton meters, and I am now pushing filament in. I did not completely remove the cloggage from the extruder, from the nozzle, so I am brute forcing it. But this length of 15 centimeters to the hot end from the extruder is not good for me, so I need to push it manually with my hand. I heated the nozzle at 220 Celsius. Now I will do pushing and cold pulling and pushing and cold pulling until I have removed all the debris. And we can say here that I am pushing, but I have turned the temperature down on the hot end, and now I am fixating this filament in order for it to cool and pull with it debris. And after I have done this, it was still clogged, so I used needle for unclogging, and I pushed this cloggage up and removed it from the needle. And after this was done, everything then extruded fine. As we can see, filament is going through, and at this part I am frustrated with this extruder, and I have found the all metal extruder in my toolbox, in my spare parts box, and I have replaced it then with that regular extruder, and we will see now the first layer that I have printed perfectly. Very nice. In my opinion, this is very nice perfection. Especially with these solid printers, they're really hard to calibrate, so this is very good. Now I of course applied some glue. This is the setup. Now I'm using Creality HyperX Hyper filament, and we can see that it is printing really good. I'm using Orca Slicer or Bambu Lab Studio. They are relatively same. And we can see I am using still the old extruder, but at the end I decided to replace that extruder because it's used for different setup, and we can see now I removed zip ties, put another extruder, and the printing is really good. Now it needs some calibration on retraction length and multiplier for the filament, but there is the layer height and the layers are good. There are some variations, but I think that they are due to software used. And that's it for the video. This is successful repair, everything works fine, everything is lubricated, and I hope it will help you in your future endeavors. So see you.